Hi everyone, I hope you guys are doing well. For this discussion, I am looking at the L page in the Excel document, and this one has a sample size of 280 babies that were born in Iowa in the year 2000, and that is out of a total population of 38,000. And the variable that we are looking at today is the low birth weight variable, and that is shown here in this column with the zeros and ones. A 1 indicates that the baby has a low birth weight, and the 0 indicates that they do not. So the first thing I did after that was calculating the average, just using the Excel function and selecting this column. And the other way to calculate the variable was counting up the number of ones and dividing by the total number in the sample. And after doing that, I went ahead and made my histogram. So one thing I couldn't figure out was how to make the bottom bins just show 0 and 1. Currently, they show 0 through 0.5 and 0.5 through 1, which in this data set is not an option. There's only zeros and ones. So if anyone knows the display setting to change that, just let me know. After making my histogram, I looked at the normal model assumptions and conditions, and I believe that my data passes the independence assumption, the 10% condition, which is it should be less than 10% of the population, and it also passes the success and failure condition. So after looking at those, I went ahead and calculated my standard deviation here. And after that, I went ahead to find my p-hat, q-hat, and my sample size. So the p-hat is looking at the proportion of successes in the sample, so that's the 19 divided by 280. And q-hat is essentially just 1 minus p-hat. So that's how I got those numbers. At this point, I went ahead and calculated my standard error. So that equation, it's the square root of p-hat times q-hat divided by n. So I did like the inside part first, and then I just took the square root of that. I just broke it up for some reason. So that number is right here. And the next thing I went to calculate was the margin of error. And so in this discussion, we're operating at a 95% confidence interval, and we're using z equals 1.96 as a result of that. So that's just p-hat times our standard error, and that's this number right here. From there, I went ahead and calculated the upper and lower limits. So that was just taking my p-hat and then adding or subtracting this margin of error right here. So as you can see, I got 0.097 and 0.038, which correspond to these percents here. The next step after that was moving over to the number line. So the way that I decided to show it on here was to show the confidence interval in the upper and lower limits. I use this green line here, and again, that lower limit is 3.8%, and the upper limit is a 9.7%, and I went ahead and showed my p-hat value as a blue p right here, and then I added the population parameter as a red p right there, and that's it'd be 5.5% essentially. And from that, we can make the conclusion that I am 95% confident that the true population parameter is between the 3.8% and 9.7%, which, as we can see, the population parameter is within that confidence interval. And yes, so I guess the data showed that with a 95% confidence that this value was located in there, and it was. And compared to my p-hat, or like my sample, it was just a little bit lower than that. Yep, that's all I have for this.